Good evening and welcome everybody. This is Obi-Wan Pass for a late stream. It's supposed to be, supposed to be on something like an hour and 40 minutes ago. It's fine. So tonight, we're going to do some math. I think first things first, we're going to get into our class stuff that we did last night and make sure that we actually copy this down. I.e. take screenshots, because otherwise I'm definitely going to forget. And our conversation that we had with Zach yesterday is going to just collapse. Never to be seen again. And no, Laz, it is not a actual fire hydrant. But like I said, you're just going to have to find out and be awed or horrored at what you're going to see. That's fine. You got it. And you asked for it. Alright, so I'm going to encourage everybody to get up and find a space available because this is a workout. So congratulations, Laz, you've doomed everybody, yourself included. Alright, 2024 0813, that's today. Cool. So we rename 2024 0812 because that was yesterday. DE01, copy. And then we paste in the name with DEO. And then copy or paste in the number. So 1, 2, 3, 4, and 5. And we'll get those uploaded to Discord in somewhat short order. You know what? Let's just open up the window anyway. Differential Equations Forum. Post 2024 0812. Non-homogeneous systems and general solutions. Do not copy paste, just nope, hang on. We need to drag those over. Yeah, cool. Alright, what do we got? That's number 1. That's number 2. Good. Alright, they're at least in order. So we don't have to spend our extra time figuring this stuff out. Alright. Alright, everybody. So, here's how we do what are lovingly called hydrants in our martial art. So what we're going to do is you get down on all fours And like any good boy that we know, all those dogs out there, you're going to lift your knee basically straight out from the ground. And then repeat that a number of times. Then on 10, we hold. And then you point your toes downward. And we're going to kick out to this point. So we go 10 times. On 10, we hold. And we go up and down 10 times. And on 10, we now do a figure 8 10 times. All the people in my class hate me very much because I like doing these. And I think one more for good measure, and then we come back and down gently. And then we do the other side. So we go 1, 3, 4, 6, 7, 8, 10, hold up, point toes, and round kick out. 1, hold out, flatten into like pointing your heel out, and then just go up. Hold up, and figure 8. And then up, and back down. And then since your butt is probably hurting quite a bit, you just kind of get down and stretch out your gluteus maximus. Because, my goodness, that one is actually quite a workout. So we did that as one of our warm-ups in karate pretty much every single time. Yes. All of the motions are repeated 10 times. On both sides. It also does not help that this used to have a gin and tonic in it. Woo! Oh yeah, joints crack very nicely. Da-da-da. I guarantee somebody's going to clip that. All right. So we just did this, and that means that we can clear. We can clear all this stuff, nothing else. And now when we come back, this will be at least a bit nicer. Oh my goodness. It's definitely a warm-up that gets you going and like gets your heart pumping no matter your fitness level, because if you're more fit, generally speaking, you know, your limbs are heavier. So yep, this is a Wacom Intuos. Let's see, it would help if I wasn't just bouncing all this light in like every direction. CTL 6100 WL question mark. I think CTL, yeah, I think it's a 6100. it's hard for me to read just because there's light bouncing everywhere. So me personally, I like this one a lot better than the others that I have had in the past. If you've got like an iPad with a stylus, my coworker absolutely loved it. So if you get like a Apple Pen, I guess, it works great. I would say that this is probably comparable, but it's a specialized piece of electronics. And I would also definitely recommend getting an artist glove because this thing slides across the board very nicely. These are $8, I think, something like that. And they're just made out of like the same sheer microfiber / polyester or whatever that a lot of other stuff is, but it definitely keeps like hot, sweaty hands from sticking all over. Yeah, so I prefer it. And if anybody has any particular questions on math tonight, feel free to ask. Yeah. Did that, did that, did that, and did that. Cool. Just had to make sure we got all of our other redeems off the board. All right. So for tonight, let's see. I think we're going to talk a bit about some of the other stuff that we're doing in differential equations. I can bring over our curriculum for that one. Nope, it's on that one. Yeah, we just... Okay, there we go. Alright, so session 10 is going to all be about probably talk a bit about the Jordan form diagonalization. We didn't do anything on Jordan form, in fact, so yeah, we're going to need to talk about that. And then and then we need to talk about the general and particular solutions, non-interacting. Duplicated. Non-interacting. The hell did I mean by that? Oh no. And then did I put linearization all the way at the end? Yeah, it did. Okay. Well, that's interesting because that's the next thing in my actual curriculum guide. The things that I taught. I think that this is going to actually be better here. So let's... We're going to reassign topic 9 to here. have to change all these. Cool. 6, 7, 8, and 9. Okay. Craziness. It's gonna be awesome. Anybody who just came in, good evening and welcome. My name is Obi-Wan Pez, and this is NSimplex Pachinko. We are doing some math tonight. We are talking about our curriculum for differential equations, and if you are not here for that sort of thing, you are welcome to ask any sorts of questions that you would like in the chat, and I will attempt to answer them. We also have several other math streamers who are available. Known rather lovingly as the Math Chads, we have Dawn Does Math, who is live tonight. Zach at e to the 2i pi, who was on just a bit earlier. Penn Center, who will be on a bit later, doing a class on complex analysis. Zach also taught a class on real analysis in the winter. He is going to be teaching a second part called Infinite Series in the fall, starting in September, and he's going to plan on doing a third part, which I now forget. He hyped it last night. I completely forgot what it's called. He's going to be doing a third part of real analysis in the spring as well. So that's going to be our third foray into real analysis. And I am looking at whether or not I can join up with that particular one. It all depends on when everybody else can meet, because I'm in England, and they are not. We also have Ian Stuckey, who is one of our other math friends. Obi, that's me, and Simplex Pachinko. And we have Danny Highway, and we also have Dr. Gold at Actual Education. Danny and Dawn are trained professional math tutors, and Danny has worked and / does work for Chegg. Dr. Gold at Actual Education runs a nonprofit that aims to teach as many people mathematics as possible. So he's got some good work. He also had me on this past Friday. Thank you, Dr. Gold. Onto an Ask Me Anything podcast. So we had a good time, had a bunch of good questions, talked at length about a number of things, and I tend to ramble because I'm a bit of a storyteller, so I thought it went well. All right. So let's see. This means that for tomorrow we are not going to be doing nonlinear systems, and instead we want to talk very carefully about, one more time, we want to talk very carefully about Jordan form first. And then what happens to each individual type of general solution when we have homogeneous in particular function types which are not the same type of thing as each other, and then what happens if they are the same type as each other. So duplicated. I got it now. Okay. So we did talk a little bit about that this week, or yesterday, last class, and we're going to talk about more of it tomorrow. So let's look real quick at what do we have for Jordan form of a matrix, and why do we care? Really? Jordan is not found in it? That is some nonsense. I mean, like, I guess it's theoretically possible, but no. Like, Jordanian form is something that you talk about. Am I, like, going crazy here or what? What's the... Oh my goodness. Uh-oh. Oh no. It's wrong. Constant coefficient. Homogeneous systems 1, homogeneous systems 2, and homogeneous systems 2. How somebody has not caught that in the last 11 years is beyond me. Is it really just not fat? That's gotta be, that is nonsense. How do you not write about Jordan form of a matrix? It's like one of the most basic terms that you come across. Oh my god. Alright, cool. We're just gonna get gaslit by this thing. And it's also possible that Trench was just not terribly happy about the term, you know, or the finding a Jordan form of a matrix and just been like, nah, it's nonsense. You just need to do the process and not call it something in particular. I am now looking into Erwin Kreyszig's book. I know we did have a somebody came in and was like, dude, I have that book. And that was like a recent engineer. This particular book is all about engineering math in particular. It was intended to teach engineers and physicists how to do the rigorous mathematics that we needed to have in order to essentially pass undergraduate math. So this was the one that I chose, or the class that I had to take in order to get into my master's program, which I definitely had an A in. That was only because I'd taken, you know, the material before, and it was just recalling a bunch of stuff. Alright, formulas for inverses, Gauss elimination, diagonal matrices. Playing the blues? No, you meant the Astral Dreams one? Yeah, possibly. We had a book. I think I got rid of it. Probably gave it away to my I just dropped a bunch of my books at my community college. It was just like, here you go, have fun, and just left. It was a little ridiculous. Okay, let's... Gauss-Jordan elimination. Okay, we've been doing that. Jordan form of matrix. Wilhelm Jordan, German mathematician and geodesist. We do not recommend this as a method for solving systems of linear equations, since the number of operations in addition to those of the Gauss elimination is larger than that for just back substitution. That's fair. Using non-singular matrices, etc., etc. Okay, uniqueness of inverses, existence of inverse, fundamental theorem. See also section 20.1. Gauss integration formula. It's 19. Gauss elimination, yeah. Ooh, write a program using to do Gauss elimination. Yeah, doesn't help. Jordan form of a matrix. Diagonal matrix that consists entirely of Jordan blocks, which is an eigenvalue. Jordan block with an eigenvalue lambda is a square matrix whose entries are equal to lambda on the diagonal equal to 1 right below the diagonal and equal to 0 elsewhere. Jordan chain. Yep, okay. It's interesting. They also leave out the zeros in this particular one. So this is saying that our Jordan matrix is going to be again, lambdas along the diagonal, 1 directly underneath, lambdas along the diagonal, 1 directly underneath, and zeros elsewhere. That's fun. 4x4 with eigenvalues 0033. We should have this 0033. Interestingly, right, I don't know why it is 1 here and nowhere else, but that's just me. Anyway. I mean, I guess if my books are not dealing explicitly with Jordan form, then we shouldn't really care all that much about it. go through this real quick. Just to make sure there's not something that I actually need, right? Because that would be rather embarrassing.
When you realize your laundry can still hold on to germs.
Boo. Go away, ads. You know, when I got off of the window that contained YouTube, it should pause it, but apparently not. Okay, fundamental theorem for linear systems. Let A be an n by n matrix. Okay, x dot is equal to ax. Cool, we got that. It's your typical differential system. Prove that x equals e to the at, where a is a matrix. Yeah, we were talking with Stuki about, no, we were talking with Zach about the issues of raising e to a matrix, and yes, that is a thing. So I don't think I really ever understood it really well, so it's always fun. Let A be a complex matrix, with A being complex numbers n by n, n being a natural number, eigenvalues lambda sub j. Okay, so the jth Jordan is going to be given by, again, lambda sub j along the entire diagonal, and it looks like 1's directly above that, because these are equivalent. Right, so whether the 1's are all above or all below the eigenvalues, it's not going to matter which one. The form will take a slightly different shape, but it's a triangular matrix. Triangular matrix is what we're trying to get at. So all of our particular entries that are not 0 end up in fact, they just end up in those two diagonals right next to each other, whichever one it's going to be for you. Using notation from definition 2.1, Jordan form, express the solution given here. Okay, solution of 1, is given by this nastiness here. P matrix is, right, P inverse AP gets us our Jordanian form. P is the matrix of eigenvectors. That was our T that we were talking about before. So this is a diagonalized matrix with zeros elsewhere. And A should therefore be P times our Jordanian, or T times our Jordanian form times T inverse. Been a while, but I think I remember that. Fair enough. N sub j is the nilpotent of order m sub j, and hence we have zeros underneath the diagonal. This becomes a triangular matrix, 1's along the diagonal, t's above that, t squared over 2 factorial above that, etc. That's just a bunch of integrals, looks like. We may be getting into stuff that I don't remember. Okay, so if we have x of t equals p of y, that was our ty from last class. Then we find a solution, y prime is equal to jy, which could be split up into uncoupled solutions. Yeah, we did that before with our T matrix. And because of that, we also did our T inverse AT, which was our D matrix, the capital D, which gets us just the eigenvalues along the diagonal and nothing else. So that's a bit different, right? Because our Jordanian matrix also includes ones directly underneath or directly above all of those values. I can't remember if there's some reason in particular that there are ones above or below, like if it's only on duplicated roots or something like that. Yeah. Right, given this, we try to find the eigenvalues. We have eigenvalue 2 with multiplicity 3. Oh boy. Okay, so the dimension of the kernel of that is going to be the dimension of the kernel of that, which is 2. Here we can easily find two eigenvectors, 1, 0, 0, and 0, 0, 1. Step 2, the algorithm. Choose 1, 0, 0, 1, 0. Now this choice now has to satisfy. Right, so doing eigenvectors as our lowercase v sub 1 with superscript 2. Lovely. It's going to be equal to capital V sub 1 superscript 1. Therefore, it needs to be 1, 0, negative 1, which is our second column. Okay. No, that makes sense. So we're getting rid of our eigenvalues in this thing, right? It ends up subtracting. We end up getting this nasty thing here. And when you take its determinant, you end up with just 2 as your only possible answers. No, that's this. That's that up there. I'm not sure really where delta is in all of this, but what is delta? Number of Jordan blocks. Delta. Yeah. Not super important. Oops. Yeah, I just went way too far. Yay. Okay. Is that it? No. Now, we had a different example, I thought, than that one. Yeah, that was the one we did. Okay, 2, 6. So if we look at 2, 4, regard the initial value problem here. 3 eigenvalues, each with multiplicity 1. Okay, cool. So we get eigenvectors given here. Can now write T, J, T inverse. T has to be this thing, which is our concatenation of eigenvectors. This is our diagonalized matrix, which again is T inverse AT, is just going to get us this thing. Damn. Just get us this thing. Okay. Solution is going to be this thing. So we allow the e to the jt ends up getting us all these individual bits. So we're looking at taking the individual pieces of J, which we had as our D matrix, and because it's diagonalized and because it's only eigenvalues, those are going to fill in the blanks in each of those locations. So it ends up being e to the 1t, e to the 2t, and e to the negative 2t. Okay. So that's going to get us this stuff, which then allows us to find a solution. Okay. Define deficiency indices as the following. Lovely. Delta sub k is the number of 0 rows in the reduced echelon form. Okay. So that's the number of free variables. Okay, that's interesting. Yeah, so that's the number of free variables we're going to have. So when we input our eigenvector matrices, right, we get 1, 0, negative 1, 0, 1, 0, and 1, 0, 0. Zero, 0, 1 is not one of our eigenvectors at this point. As delta 1 cannot be 3, we have to proceed with step 2 of the algorithm. Therefore, kernel of a minus lambda I squared has to be the kernel of 0. So it gets us 0, 1, 0, which then essentially blocks 0, 0, 1. Jordan blocks or something that ends up filling out those spaces particularly. Yeah, it's been too long since I've done that, but essentially, yes, we're not really interested in the Jordan form of matrices. I think I would need to have the Boyson to Prima book, which I no longer own, so challenging. In order to actually talk about like Jordan form of matrices, but in this particular case, we're going to be good for now. Okay, so we were dealing with systems that had different kinds of behaviors. So in here, our null space solution is irrational. So therefore we don't have any problems with that system. Okay, there we go. So there's one that is, oops, there's one that is part of our null space. Alright, so to solve the following differential equation, we're going to, let's just start it here. That'll be fine. Tab over. And there we go. This is, right, we want an arrow. We don't have vector arrows. Cool. Y prime is equal to... How did I do it in earlier ones? Yeah, just x prime, y prime. Alright, cool. Let me make it a subscript. Boo. X2 prime is equal to negative x minus the other x. So go as subscripts. Plus 8e raised to negative 3t, whereas this one is going to be plus 21e to the 4t. Again, if anybody has any questions, please let me know. Otherwise, I will just keep going forever, because that's sometimes how I do things. Got about 10-ish minutes until we want to probably run another 3-minute ad and ditch some of the pre-roll and mid-roll stuff. We want to, as much as we can, control this, rather than letting Twitch dictate everything about what we're doing. Okay. Yep, continue previous note. Nope, not what I wanted. 1, 2. There we go. Okay, so the following DE. When we do that, we're going to have the conversation that we had like from last class. We now have part of our general solution is in our null space solution. So therefore, our null space solution is going to need to be... Nope. Our null space solution stays where it is. The general solution needs to be essentially accelerated beyond... beyond the terms in the null space. In this particular case, we have a e to the 4t and e to the negative 3t. Our null space is e to the negative 3t, e to the t. So e to the 4t is perfectly fine to get its own portion of the general solution, and e to the negative 3t is already in the null space, so we're going to have t e to the negative 3t as part of our general solution. I told my students that it should get clear of the null space by multiplying by a polynomial, like subsequent terms of a polynomial, until it is no longer interacting with the null space solution. All right, where did I put nope, not homogeneous. Autonomous. Oh wow. Okay, so I did that earlier, which I literally did not. So maybe we need to talk about that. Oh, right, but we never actually... Interesting. Okay, so we never did it algebraically. Might be a good time to bring it up. Okay. So I dropped in second order ODEs immediately after. All right. Next question. How disgustingly nasty is using matrices to do variation of parameters? Been a while since I did this. Okay, so we know a fundamental matrix for the non-homogeneous, or no, for the null space solution or complementary system. To derive the method, suppose Y is a fundamental matrix of the complementary system. So this is our null space fundamental set. Okay, where we have all separate y1, y2, y3, etc. going across as vectors. Our particular solution is going to be y sub p is equal to that big Y times some function u, or some function vector u. Okay. So when we multiply this in, we're going to get a, right, big Y prime times U vector plus big Y times U vector prime, which is, we multiply, nope, right, Y prime is the same as AY from before, so AYU plus UY, no, YU was given earlier as Y sub P, the particular. Right, so Y particular prime is going to be equal to A times Y sub P, Y particular, plus Y U prime. Comparing this with 10.7.1 shows Y particular is going to be equal to Y U is a solution if and only if Y times U prime is equal to F. F. Take all constants of integration to be 0 since any particular solution will suffice. Right, so we've got our matrices. Y prime is equal to 1, 2, 2, 1 times Y vector plus 2 e to the 4t, e to the 4t, which we considered before. Complementary system is given here. We get that. Null space solution, blah, 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 blah. Okay. Variation of parameters says that we take this, we multiply it by our U prime matrix to get the thing, to get F, right? Or G as we have called it. Determinant of Y is the same as the Wronskian here by Cramer's rule, right? Why is that backwards? Ace 1 has to be opposite? Why? Okay, we got our constants, 5 and 6, to replace each of the columns in turn. Oh my goodness. Right, so instead of 1, 2, as in the original A, we get 5, 6, which is our D values, the constants. And then we divide by the determinant of that particular matrix. So the determinant of A sub 1, are we even looking at that? You're not looking at that. cool. Yeah. So using this one here, right? Cramer's rule says that if we have A being a coefficient matrix 1, 3, 2, 2, then A sub 1 is going to replace our first column, X sub 1. Instead of 1, 2, it's going to be 5, 6 from the constants. Then A2 is going to be 1, 2, and instead of 3, 2, it's going to be 5, 6. So 1, 2, 5, 6 as columns. Then we divide by the determinant of each of those things. Sorry, divide by the determinant of the original. Right, so determinant A sub 1 is -8 divided by -4 is going to get us 2. And then for A2, we're going to get a 6 minus 10 is -4. Divided by -4 is just going to be 1 for this one. So 2 plus 2, 1, 3. 2 plus 1, 3 is going to be 5. And then here we have 2 times 2 is 4 plus 2 times 1 is 2, which makes 6 overall. Okay, cool. So here, going to use that Cramer's rule in order to solve this thing, right? 2e to the 2t. Okay. Also wanted to give a shout out to somebody who has been playing Outer Wilds on YouTube and is also a Twitch streamer. So thank you very much to Maisie, who has also expressed interest as a streamer in going back and educating herself more on mathematics and, well, specifically astrophysics and astronomy. So I did want to highlight a couple little cool things here. Some books that you might be interested in if you happen to be in the area. If you happen to see that I shouted you out and you're here now. So Neil deGrasse Tyson's Astrophysics for People in a Hurry. It's a good little book, decent starter for like how to understand the universe if you haven't already. And I really apologize if this sounds at all patronizing. That's not what I'm going for. Jenna Levin wrote a book called How the Universe Got Its Spots, and she is a frequent guest on Neil deGrasse Tyson's podcast that he does oftentimes with Chuck Nice, and that one is Star Talk. So also a good one. If you like podcasts at all, Star Talk is a good one to kind of get steeped in like the information about how the universe works and other cool stuff like that. I can't speak to this particular book, but my my mother bought me The Little Book of Exoplanets by Joshua Winn, W-I-N-N. It looks like it goes into some detail. Doesn't appear to be like, you know, hard math or anything like that, but it looks like it does go into at least some detail mathematically about like how to back up all of the claims that have been made about the universe. And for anyone who's interested in science history, I recommend Bill Bryson's A Short History of Nearly Everything. This particular book I came across when I was grad school, I think. My mother really loved Bill Bryson's writing. He's not a trained scientist or anything like that. He's been doing, you know, columns for a long time, and he decided to go hike the Appalachian Trail, go, like, take an extended vacation in Australia. In this particular case, it was take an extended vacation to study science history, and he's gone through a whole bunch of stuff there. It's really accessible to anybody who doesn't know science history already, and most of these books are available in your local library or through the library system that you have with surrounding towns. I left a lot of my other collection at home because it was ridiculously large and I just didn't need it. I am regretting not bringing my copy of the 25th anniversary edition of A Brief History of Time by Stephen Hawking. That's a good one. It's a little less accessible, so like you ought to know your stuff, at least to like the PBS Nova Science Channel level of understanding of physics before you get into that kind of stuff. Some other fun reads, Charles Zaifa, Alpha and Omega. Again, coming up with understanding of how cosmology works in general. Brian Greene's The Elegant Universe. I believe this is mostly about string theory. Dr. Brian Greene, who does not really look like this anymore. Yep, in this picture he's looking about my age. That was 1990 something. Nah, can't be quite that long ago. And anybody who's interested in other just cool stuff, if you're all into science-y type things and you want to understand more about evolution, Richard Dawkins' The Blind Watchmaker was my introduction into this. It was, it really dovetailed well with my understanding of programming. Because in it he actually produces a simple program on a simple computer in order to evolve like little creatures that just have some basic rules. And wow, wouldn't you know it, if we just input some basic rules into this whole thing, we get a wild complexity of so-called organisms that come out of it. So it's just an interesting read. There was something else I wanted to get into. Oh, no, that was somebody else. I was chatting, or rather, I marked a couple of things and was like, you know, somebody on Twitter was upset about people having an embarrassing level of understanding about culture, and like, you know, the fact that people thought that a whole bunch of the Olympics opening ceremony was like, you know, satanic or something like that. And she was going on a rant about how people have lost, Americans specifically, have lost their touch with, I mean, reality, but with specifically culture and mythology and like all this stuff, and how like people don't do coursework, formal coursework in humanities. So I was lamenting that, well, realistically, like these days, we try as much as we can to teach some of the humanities within our subject, and so I do try to keep math history as part of my math courses at the very least, because there is a definite human element behind all of these things. Who are these people? What have they done? Not just what did they do and how does it work, but also like what's their individual story. So I try to get students to kind of look up some basic biographies of these people and, you know, understand better that this isn't just some list of facts and figures, that everything that we're doing is much, much more important. And, you know, some people will struggle at their individual problem, you know, the thing that they've been working on for days, weeks, months, turns into years, turns into even decades, just to push the ball forward just a little bit in their lifetime. So I attempted to refute that point, but you know, I'm not super eloquent, but we'll see how it goes. All right. This is particularly man, I definitely did not get into all these individual things. I mean, most of it I did, but yeah, the talking about, like, we didn't really do graphs of first order systems. I mean, we did a little, but we didn't do a lot. Null Klein's behaviors by inspection, we didn't do any of that. We just pretty much went straight to matrix form from like the expanded form. Whoops. Man, having a rough day there. We do this by undetermined coefficients. Okay, and then we want to also do this by variation of parameters. Right. This is just a matrix multiplication of our null space solution. I did not mean that, so you should just add that to the personal dictionary. Okay. Undetermined coefficients is easier than Jordan-Foreman diagonalization. So it makes sense that that is before. And essentially, diagonalization is the same thing as the variation of parameters, but it's formatted in a slightly different way. I mean, I guess we did do null lines because we were talking about that. I didn't bring up the word, right? But we did do the phase plane stuff. That's right. And then in doing that, right, that's where we actually get the... I don't think I did relationship to first and second derivative tests in Calc 1, but it's not terribly difficult, right? Relationship to first derivative test, we're saying that anywhere that there is a maximum value, we're going to get those horizontal tangent lines. Anywhere our second derivative tests are 0, we end up getting the inflection points. And so we can see those things within our matrix, or within our phase plane, because anywhere our first derivative, which is generally speaking the form in which we're given, is equal to 0, or in this case our 0 vector, we're going to have some particular point, which is going to be some particular critical point. When either x or y is 0, but exclusively x exclusively or y are 0, then it's moving in a perfectly horizontal or perfectly vertical direction. And then when second derivatives are 0, that's when either we have a straight line, so like our null lines, or we have an inflection point if it's an individual point. Okay, I think we pretty much discussed that. Alright, yeah, I don't think we need to go back. Well, looks like my parents made it home safe. Or at least to Boston, where they can then go home. Alright. drop this off to the side so I can still look at it. And then here, right? So how do we find the inhomogeneous or general solution? This is where we start talking about most likely the person who's doing this, it's either going to be Zach or Stuckey or both, are going to say like, well, we try to find the inhomogeneous solution by saying in this particular case that e to the 4t and e to the negative 3t need to be part of the particular solution. As it turns out, e to the negative 3t is part of the null space solution, so they need to expand it out and say it's te to the negative 3t could be a part of our linearly independent solution. So therefore, what happens So what happens if the right-hand side contains a function that is not part of our usual set of solutions, like tangent? What if the what do we call that part? There's some way to say it. Does F have a name? Non-homogeneous linear system. Yeah, okay. So we're actually going to bring in, are we actually going to bring in? Yeah, I need to actually discuss. There was one question that I just like kept kicking the can over and over again because it didn't make sense to put it where I was putting it. But it actually makes sense to put it in. Well, it made sense to put it in last class, but I ended up just discussing with Zach how to do it because a lot of the stuff we did last class was mechanics rather than like theory. Possibly it was terribly boring for everybody. We'll see how it goes. Tell you what, I am going to go and refill my water, and I recommend everybody go stretch, hydrate yourself, cycle that water through, and I will be back in 3 minutes. Thank you so much for coming, and we'll be back soon. My name is Obi-Wan Pez. This is N Simplex Pachinko, and yep, thanks for coming. Well, 1 minute late, so, you know, close enough. Oh, man, got it. Had this little gnat buzzing around earlier. Got him. Also need to trim my beard, because goodness, it's getting super long. I can actually see it like over my teeth. There you go. Looks like I'm missing teeth when I do that. It's awful. Tonight we went with one of Britain's favorites, the hashtag not sponsored hobnobs. Milk chocolate. And blueberries. Earlier we had some gin from a company called Masons. Again, hashtag not sponsored. And this particular one has like tea mixed in with it when it's like distilled. I don't understand how that works, but it sounded interesting. And yeah, you can actually sort of taste it. Alright, so what if our right hand side, and really here we're talking about, right, that separate vector matrix. So I guess that's kind of the non-homogeneous portion. Contains a function that is not part of our usual set of functions like a tangent. So what we want to do is follow the logic that sub p vector exist as a product of let's see, so what was it again? Alright, null space solution is the complementary system that we have here, or the null space. No, that's the we call it the homogeneous system usually. It's the non-homogeneous portion of the differential equation is the other part. Here they're saying it's the complementary system. y is going to be the concatenated version. Fundamental set matrix created by concatenating our solution matrices for the null space solution, and U just another vector of that we're trying to find. Another thing we're trying to find. Right, it's a dummy variable in this particular case. U is to be determined, yep. Really want this to be a vector. The problem is we can't actually put like a line over the top of it. It's ridiculous. I mean, we could put a line over the top of it, but we can't put an arrow over the top of it. Which is the same size as x of p. I really want to be able to bold this. Grr. Doesn't actually let me do it. That's fine. Alright, so we mentioned that this is variation parameters, and then we say, okay, step 5 is going to be repeat step 1, solve that following differential equation, but use variation of parameters instead. And then we should get the exact same solution as we did for undetermined coefficients. I guess if we have time, right? Mean. Take this, copy it here. Take this. Oops. Okay, and then literally. Don't have a function name? No. Why would I? Of course not. Tangent of t. I don't know how ill-advised this is, but we can try, like, natural log of t. It'd be crazy. Right? We'll see if this works. There's a distinct possibility it will not. Nope. Definitely not. Man, you're awful at this. What are you doing? Alright, get rid of these subscript things, because that could just be ruining everything. Get rid of this X and turn it into Y. Oh, there's Y prime. Nope. Still awful. Man, I told you it was a system of differential equations. Just don't believe me. Fizzbuzz, thank you. That's interesting. x1t minus x 4x2 of t plus 21 e to the 4t. x2 prime of t is equal to negative x1 of t minus x2 of t plus 8 e to the negative 3t. In another place, we have this stuff combined to make x to the 7th, x to the 7t correct, or as part of the solution. That troubles me a bit, but maybe it's absolutely right and I just don't see it. Oh man, they factored out e to the negative 3t in a bunch of places. That might be why. I hate it. Yeah. So yeah, it's correct. It's just really annoying. Righto. So we get our homogeneous solution, right? C1 e to the negative 3t multiplied by e to the 4t plus 1. So that combined is going to be e to the t, and then this is going to be e to the negative 3t. And then C2 it's going to be e to the t and e to the negative 3t again with constants, and these things can then be brought together as part of our null space solution as just functions of e to the t and functions of e to the negative 3t instead of this weird mix thing that's going on here, where we have e to the 4t, which doesn't make any sense in terms of like being a part of the null space solution, but it's okay because when you multiply it through, you get the two pieces of the null space solution. Oh my goodness. Alright, this is going to be t e to the negative 3t. This is going to be e to the 4t, and this is going to be e to the negative 3t, which is part of our null space solution. So this thing just has some issues recognizing like proper formatting. Yeah, like you can't mix your null space and particular solutions as part of your particular solution. Like, okay. Now let's do something awful. This is tan of t, and this one as ln of t, and then see just how awful this makes it. It is also possible that this is, yeah, there we go. Exponential integral EI. Hypergeometric stuff. Oh yeah. That's just great. Nope. Alright, so that's at least reasonable. Slide tangent on the first spot. It's probably hypergeometric again. Yeah. Alright, well. Thanks for the lurk, Frizzbuzz. We'll be going for about another half hour or so. And we're going to find somebody to raid after that. I don't know who's going to be on. Well, Pen's going to be on, but that's like at 2, so I don't want to be up that late. At least I don't want to be on stage that late. Alright, so let's play around with this a little bit longer, see if we can't get something that's not quite as disgusting. I get the feeling that this one's going to be just anything that I try to do. It's going to be pretty gross. In which case, we should probably just look at the trench book. Oh, yeah, we could just do, like, higher degree polynomial. And say, make what you will of that. Like, t to the 4th. I would not want to go through necessarily. Yeah. It's like I would not necessarily want to go through this and have to do an undetermined coefficients that has 5 individual terms, but if I could do it as a part of variation of parameters, it may make it a little bit easier to work with. That lurk command was supposed to work. And it's possible that it's just awful. Yeah, I didn't think so. Yeah, let's do that then. Nah, that's big numbers again. Alright, so we'll leave it like that. Compare and contrast. Right, compare and contrast the process that we would have needed to undergo with undetermined coefficients. So that makes it interesting. Alright. If anyone has any other questions, let me know. Otherwise, I think what I'd like to do is something a little bit off the wall, which is I would like to attempt to install on stream. I am not going to show you the actual terminal output, so we'll just leave that aside. But, coward. But there was a video that I was watching to attempt to get me to do it. Installing DaVinci Resolve on Ubuntu 24.04 because I am having trouble actually making this work. So I think I would like to give this guy some press and also try to get it to work in real time so that I can start editing videos, because goodness, I would like to post some of this stuff to my YouTube channels. Alright. Let's also get rid of the Really creepy, weird music. There we go. Alright, so this is some assembly required. I don't know who they are. Compusar. Shashar Shemesh, looks like. Okay. And we're going to jump to the part where we have overcoming the missing packages error. Because this is exact.
If Galaxy chocolate tastes good to
Da, 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 da. There we go.
Now, you should be able to install these packages, except most of all of those are either already installed or installed but have different names.
We're having some issues with the audio. That's awesome. Okay. So this is exactly the issue that I'm having. Where I had attempted to install DaVinci Resolve, and I got all of these errors which say like, here, you should install this package instead of this one, or select using this package instead of this one. When I did that, it said, hey, you don't have that package installed. So like, okay, so I installed all these packages, and then it went back here and said, hey, you should probably use this other, or you don't have this package installed, the old one. So I'm having a little bit of a frustrating time with it, but so we're gonna try to, let's see, where did I store? Okay, CD space, DaVinci Resolve folder. Unzip and CD space DaVinci Resolve 1866 _ Linux. Alright. So now we have a .run file and a .pdf file, which are in our which are in here. And as you can see up here, he has this .run file, which then he tries to use, and then it says missing or outdated system packages detected. Please install the following missing packages. Use skip package check equals 1 to bypass the system package check. So that's pretty much what we need to do. Here he said, okay, install all of the things that we are missing, and then when it did, please select these other ones. When you select the other ones, it then says, again, you don't have the old ones installed.
So, for example, for lib.a sound 2, you need to choose either this one or this one, and the rest have been renamed. That's the reason that the DaVinci Resolve installer couldn't find them.
Oop.
So make sure they are actually installed with the new names, and then it's actually giving you what to do in order to skip this stage. You need to set skip package check to 1, and then you can
Okay, so we need to skip package check equals 1 space. Okay, and then here we're in this particular directory already. So this is just saying we want to run the DaVinci Resolve underscore 1866 underscore Linux dot run file. Command not found. Cool. Hmm. 19.0b3 underscore Linux dot run. Okay, so let's include the dot slash that he's got at the beginning, I guess. Hey, it did a UI. That's nice. I like having a UI.
Run. And the installer will start,
Hey.
and at least for 19
It looks
beta
like that.
3, for me it also finishes, which is really great, except it doesn't help us much, because it still won't run. We get this error, and nothing else happens. This also happens if you try to run it from the icon it created, except you don't get any actual feedback. It just, nothing happens. That's why I recommend running it from the command line. At this point, I'm going to explain what's going on. If you don't care about, if you only care about the solution, use the chapter markers to skip the explanation. Blackmagic did not trust the system to have all of the dependencies. For that reason, we have a directory called libs under the DaVinci Resolve installation that contains a lot of the libraries that they need. Now, some of them, for example, libbmd audio plugins, are probably specific to Blackmagic design. Others are completely standard libraries that
BMD, right?
Blackmagic did not trust our system to have. The reason those runs don't succeed is because a library in the libs directory requires a library that is outside of the libs directory, and that creates a conflict. Now, in the past, what I would do is I'd rename some of the libraries in the lib directory and have DaVinci Resolve completely depend on the libraries installed in the system. This stopped working in the latest update. So what we're going to do instead is download versions of the missing library that are still compatible with what DaVinci Resolve needs. Now, DaVinci Resolve does run successfully on Ubuntu 22.04, so that's where we're going to grab the libraries we need. So right now we're looking for libpango. So we can go to the internet and ask for Ubuntu 22.04 download. Now, if you're using a proper search engine such as DuckDuckGo, what you'll get is a link to a packages site that contains historic packages. So this is the libpango as shipped with Ubuntu 22.04. It should also be possible to get this through the Ubuntu sites. So we can go libpango, and then we can go for Jammy and download it from here. Obviously, we want the AMD 64 version, which is the version for 64-bit Intel. And now we can choose a mirror and download it. Of course, we need to tell the system that it's not a security risk. So now we have a deb containing the version that should work with the Blackmagic. Except I don't want to install this in my system. I already have libpango installed. I don't want the older version. So what we want to do is extract this package without installing it and extracting the files we need from that package. We can do that with the dpkg deb command.
Okay. So if we go back to where we were, right? If we did sudo install of this run file, then it should throw a fit at us. Unable to locate package despite the fact that it's sitting right in front of you. Cool. Is it dpackage? Oops. No, because it's a run file, not a... I'm smart, I promise. Okay. So we have this. Go into home. Whatever my unzip directory is. Okay, missing or outdated packages detected. Right. Okay. Yeah. libapr1 is one of the missing packages, but libapr1t64 is already the newest version. So, yeah. So we need to find right. Let's try it now. don't think anything happened. Just like he said, right? It was that we were having issues. Okay.
And -x will extract the package. We tell it to extract it to temp dir files. And now we have all the files that came with the package, and under lib we have the files that relate to the correct version or the incorrect but matching version of libpango. So what we can do now is we can run Resolve again, but tell it to look for library files in this directory. You can do this by setting an environment variable ld library path to this directory.
So can we do that? App details? Nope. That is not it. What I want to do is to be able to set some sort of, like, set that path using Did it freeze? It froze. Oh no. Huh. That's really weird. I moved up to 7 minutes 11 seconds. Select window. Okay. Like, I'd like to set that environment variable. Or in bash.
So what we can do now is we can run Resolve again, but tell it to look for library files in this directory. You can do this by setting an environment variable ld library path
Okay. I don't think this is gonna work, but it was worth a shot. Let's run over and check out Don Does Math, and he will likely be raiding over to Actual Education with Dr. Gold in, I don't know, probably the next hour or two, something like that. So we're gonna head over there. I want to thank everybody for coming. This has been a good stream. Thank you so much. And we'll be back tomorrow to do our next installment of the Differential Equations class, which you saw some of the creation here. And then we'll also be back on probably Friday for some gaming type stuff. So We'll see how it goes. My name is Obi-Wan Pez. This is N Simplex Pachinko. Thank you so much, and I'll see you around.